So very good afternoon to everybody in this second session of today's program. Already in our first noon, we are having two, lectures. Now the third lecture of the day, that's being delivered by PUJA THIEL. She has already joined us. She is there. Most welcome, PUJA. Most welcome. You are perhaps you are taking tea this time. Is it so?
Yes, it's 9:30 in the morning.
Okay.
Thank you.
So it's afternoon. We have taken our lunch. Where it's our after lunch session over here. So most welcome to this webinar series over here. We are grateful to you. You have spared your time and you are sharing your wisdom with us. Before I just invite Pooja for his deliberations, let me introduce yourself to the participants. Pooja THIEL, presently a program manager with Nelis Global, that's Next Leaders Initiative for Sustainability, Norway, UK. If you go for his credentials, it's very interesting to note that she has postgraduate diploma from Delhi University in Biochemical Engineering in 2003 and 4, then Masters in Biomedical Sciences from University of Amsterdam 2004 to 6, then PhD in Molecular Biology from University of Bergen, Norway 2007 and 14. So this is qualification highly qualified in the the animals biological sciences, molecular biology, biomedical sciences, and all that. She basically she mentored an international hackathon organized by the BioBase, that's a help camps and accelerator in the University of Tartu. And if you go for his impact, so she's really impact maker there. She is driven by a desire to support innovations in the field of food and sustainability. She took the initiative to bring future agro challenges to Norway. FSC is the leading global competition for startups in the field of agri-tech, food tech, agrotourism, health and nutrition, food waste, and anything that would impact our understanding and availability of food in the future. Together with other young leaders, she is passionate about sustainability. She helps build the organizational structure and develop programs within it designed to focus on innovative and impact. To be very frank, I heard him in one of the webinar series that was launched from UK, and I was very much impressed with her lecture and with her innovations, with her ideas. Very, clean ideas for this food security, sustainability. So then at that time, I realized that I should invite her in this webinar series. And I started searching for her, and ultimately I got her, and she accepted my request. And I'm really humbled to have her here with us in this afternoon. So without wasting time, over to Pooja, please. You can share your screen.
Thank you. Thank you. You've set a very high bar for me, Professor Pampuri.
No, it's not.
I'll try to catch up to it. Okay, so welcome to this talk, the third talk of a course on Zero Hunger. I'm just as pleased to be presenting in it as I would be to attend it. I'm sure you've got a list of great speakers lined up. So as Professor Pampuri said, my name is Pooja THIEL. I am a scientist by training. I've done science for years and years and years, and it didn't quite give me the impact that I wanted to make. So now I'm working as a sustainability advisor, as an innovation manager, and in various projects that allow me to do what I really want to do. Amongst my qualifications, I've written foodie. A lot of people who know me as the biggest foodie they know. And I really think on a course on Zero Hunger, that is a big qualification. I've left my doctor title next to my name, just as a warning to say I do tend to get sciencey, but I'll make everything bite-sized. So as Professor Pampuri said, I've been involved in making our food and food culture sustainable through innovation challenges, talks, workshops, and other channels. And through these projects, I get to meet people from all over the world, innovators from all over the world that are doing really great work to make our food sustainable. But as you see in the picture, I enjoy food way more than that. We all work in various ways towards food. And actually, at this point, I would like you all to use the chat function on Zoom and tell me what your passion around food is. Do you work around pesticide, pest control, or food yields? What is it that drives you towards food? What is it that you want to achieve? So the chat function would be, let me find it myself. There. I'll try to keep an eye on it. It's not very easy in the speaker view of Zoom. So the picture I've selected on to put on your screen right now is a weird one. It's me on a foraging trip in Norway. This picture is taken in July, a few years ago. July is the beginning of the mushroom and berry picking season. So chances that you come across a lush patch are a bit higher, and this was our most successful trip for blueberries. In Norway, spending time in nature and knowing the food that grows around you is a very common thing. And in fact, this is one of the fastest growing global trends around food, because we're increasingly understanding that making our food local and natural is a huge part of making our food truly resilient. Now, on the surface, we all understand that we need food for energy and nutrition. Every day, food brings us around a table with our loved ones. Across countries, across cultures, we all celebrate around food. Food shapes our cultural identities. But food has actually shaped human civilization the way we know it today. We learned to farm 11,000 years ago, and that was a determining factor. Very first human settlements, from the Levant to Mesopotamia to Indus Valley civilization, none of that would have been possible if we didn't know how to grow food. So it's not that our capability to grow food is the foundation of human civilization. But the way we grow food and our food choices may be the end of the existence of human species. Now, it sounds like a very bold statement, and I'll try to make my argument in the next slides. Agriculture today contributes over a quarter of all greenhouse gases. Greenhouse gases are a huge contributor to climate change. Greenhouse gases are famously carbon dioxide, but also methane and nitrous oxide. When it comes to non-CO2 greenhouse gases, agriculture contributes over half, 56% of all non-CO2 greenhouse gases. Many of these are very important contributors to ozone layer depletion, another major climate change problem. Agriculture uses a lot of resources. It uses 37% of the land surface for growing food. Now this slide has a lot of numbers, and I'm going to dig into numbers just a little bit more just here. 37% of the land surface. The remaining 63 consists of urban civilizations, forests, deserts, wetlands, grasslands, and lands that we cannot access yet. Some of you may come across a number. We use 50% of the land surface for agriculture. That's correct. If you exclude the lands that we cannot access, we're using 50% of all land we can access for agriculture. Numbers are hugely important because you're basing all your arguments on numbers. The way we grow food, we lose 20 hectares, which is 20 football fields worth of land every minute. By this, I mean this is land that we've overused. It's lost its fertility, it's turned barren, and we cannot use it to grow food anymore. We lose 20 football fields worth of land, turned barren every minute. For those who understand kilometers square better, we lose 1 kilometer square, that's a huge amount of land, every 5 minutes. A lot of this loss is compensated for by deforestation. So from one year to the next, you might see, okay, we're still using 37% of the land, so we haven't destroyed anything, but no, we've destroyed a lot of the land and we've had to clear new land to maintain that 37%. Land isn't the only resource. Agriculture uses 70% of all the water that goes into food production. In addition, it contaminates water. A big part of all the chemicals that we use on fields leaches into groundwater and rivers and oceans and causes huge dead zones, killing off aquatic life. Dead zones have increased from 10 just a few decades ago to over 400. It is because of the way we treat land. Now, these are just some, not all. These are some of the environmental impacts of food. But food also has a huge social impact because 1 in 4 of all working age people are involved in food production. Agriculture employs 27% of all working age people, yet it contributes only 6% of the global GDP. Put in simpler terms, it's a lot of work for very little money. So it's no surprise that young people don't want to take up farming. They don't want to be farmers. And the average age of our farmer is growing older, leaving fewer people to grow our food, especially in sustainable ways. When we look at the environmental and social and business aspects of a product, we're treating it as a commodity. But food relates to us in a much closer way than all of these. We eat it. It affects our health. There's a growing mountain of scientific data showing that the toxins in our food, fertilizers, pesticides, weedicides, they're harmful to human health. A lot of studies, scientists find it easy to do, a lot of studies are done on pregnant mothers and unborn babies. And we see diseases such as endocrine dysfunction, childhood behavior, brain functioning appearing because of the toxins in our food chain. If we move ahead on this path, the future does not look great. Climate change is going to make it more difficult for us to produce food, both directly through unpredictable weather patterns, but also indirectly through climate wars. We all hear that the world population is growing and we don't have enough food to feed the world. That's not exactly correct. We have the land, the resources, and the technology to feed 12 billion people right now in a sustainable fashion. The world population is set to stagnate at 10.9 billion by the end of the century. We have enough for everyone, but with growing economies, people will move to a richer diet. A richer diet typically relates to a Western, more meat-based diet, or even in Asian terms, a Shahi diet, more nuts, which are very carbon intensive. The mantra of the Western diet is you need protein. and our understanding of protein does not help at all. So at this point, many of you might know, many of you may not. So let's see. I'll engage you in a short exercise. I want you to find the chat function on Zoom. You'll find it, I think, at the bottom of the screen. So open it up, and I have mine in front of me. Okay, hands on the keyboard. I hope you're ready for this. How much protein do we need to meet our daily needs? I'll give you a moment. Pretty good. Okay, so those are pretty good guesses, and that's a very wide range. So the lowest estimate is 35 grams, and the highest is 100 grams. Depending on which source you look at for your protein requirements, it will give you different answers. It's no surprise that people don't understand how much protein we need. For my age, body weight, and activity status, the internet tells me I need anywhere between 40 and 150 grams of protein. That's a wide range. That's not even a recommendation. The best estimate, and this is not a lower estimate, the best estimate is 0.8 grams per kilogram of body weight. Someone here wrote 56 grams, and yes, that is the recommended dietary allowance for adult males, assuming that an adult male between the age 19 and 70 weigh 70 kilograms. 0.8 grams per kilogram of body weight for a 70 kilogram person is 56 grams. That's how you get to it. In addition, we don't understand that in one meal, we only absorb 20 to 30 grams of protein. So eating 70 grams would be a total waste for at least half of what we've consumed. Waste is another issue, a major issue that we're dealing with. 1/3 of all produce all food that we produce goes to waste. In addition, a problem that we speak about much less is that cultures globally no longer see food waste as the failure that we used to. A decade or two ago, throwing food away used to feel like a crime. Why doesn't it anymore? It should be. A new economic model states that to be sustainable, human activity has to lie within the bounds of social foundation, meet minimum basic needs, and nature's boundaries. This is the sustainable zone. Anything below that, and we would not be able to meet basic needs. We'll have hunger, poverty, unmet demand, and injustice. Too much activity and we'll burden nature's resources to a tipping point, and that's not sustainable. This layered graph looped into a tube is what it takes up a donut-like shape, and therefore it's called the donut economy model. In the center are all the things that we need, all the necessities such as food, water, energy, housing, political justice. On the outside are all the things that we need to avoid. That's climate change, air pollution, biodiversity loss. Food is just one of the needs in this illustration that we need to meet. But as you've seen in the slides before, food affects a lot of the other elements. It's important for health. It uses a lot of our water. It's a source of income for many. Done right, food can also be a solution to pretty much all of these things. Let me make my argument by starting right at the basics. This is really basic. So we all know plants breathe carbon dioxide and release oxygen. That's the first thing we know about plants. What do plants do with the carbon? You can write your answers in the chat if you like. A textbook would tell you that plants produce sugars, which they use for their own use. They use, they use sugars as cellulose for their structure. They use sugars as glucose for energy, photosynthesis. And they use sugars in their fruits as fructose. What we don't read even in textbooks is that plants invest up to 40% of their sugars down their roots and into the soil. The idea is to feed soil life. So healthy soil would be full of fungi and bacteria and nematodes that have evolved in symbiosis with plants. Fungal threads act as literal root extensions and feed the plants. They also act as communication channels through which plants can talk with each other. Plants can talk, it's just that we can't hear them. Bacteria, in turn, bacteria and other nematodes, they decompose dead organic matter and make the nutrients available to the plants in a plant available form. So with this return, the plant can now uptake all the nutrients that would not be available to it, that we would be giving it as fertilizers, but it's not a healthy relationship. This simple relationship between plant and its soils gives a disproportionate number of benefits. It gives higher plant health, increased immunity. Oxygenated soils have less weeds, necessitating the use of less weedicides. Healthier plants require less fertilizers because the soil life is doing that for us. Organic farming is said to have up to 5 times higher yields. So it's a win-win-win situation. In addition, this process sequesters more carbon into the soil and away from the atmosphere. The carbon is turned into organic matter as plant biomass, but also as soil life. And this organic matter gives the soil a sponginess and increased water retention capacity, which means our plants and our farms are resilient to droughts. This is called green water, if you want to read more about it. It also means more structure in the soil, which leads to less water erosion. And because the plants feed this water slowly into the rivers, you can get increased river flow throughout the year. This is the mantra of any organic gardener, regenerative agriculture, permaculture, call it what you will. But the mantra is to feed the soil, not the plant. Feed the soil, let the soil feed your plant. Care for the soil, let the soil care for your plants. Now you might be wondering, can this be used at scale? Absolutely. One of the first projects on restoring soil health was done by the World Bank back in the 1990s. They restored a huge part of the Lis Plateau in China, 35,000 kilometers. Now, for those of you who are wondering how big is 35,000 kilometers square, I looked it up, it's the size of Kerala. The World Bank spent 4 years researching how to regenerate such a huge mass of land, including scientific methods, but also traditional methods. And once they figured out how to, they managed to restore this part of land, which was known as a cradle for Chinese civilization. They managed to restore it to its original fertility. This project alone, it took a dozen years, but this project alone pulled out 2.5 million people out of poverty. These people could now farm, they had gainful employment. 2.5 million people, that's half the population of Norway. That's huge. Restoration efforts have taken place in many parts of the world since then. And an estimate is it has pulled 20 million people out of poverty. There are other projects as well because of the carbon benefits and biodiversity benefits of such agriculture. The Trillion Trees Project, for example, which is a collaboration between Wildlife Conservation Society, BirdLife, and World Wildlife Fund. Now you may be wondering, what do trees and forestation have to do with food? But taking care of soil life is not about trees or annuals or even wild plants. It's about managing the soil. So I'll ask you to bear with me through a little bit of maths. At the moment, we manage 5 billion hectares of land for agriculture worldwide. A conservative estimate of how much carbon we can sequester into the soil is 10 tons per hectare per year. Which means if we could start just like that all over the world, we would start sequestering 50 gigatons of carbon dioxide every year. It gets better. Current levels of carbon dioxide, atmospheric carbon dioxide, are 416 parts per million globally. Scientists have told us that the safe levels are 350. We need to stay below that. Historically, atmospheric carbon dioxide levels were 280, 300, not above that, but scientists have told us 350 is still fine. 1 part per million of carbon dioxide is equal to 7.76 gigatons, which means you emit 7.76 gigatons and you increase atmospheric carbon by 1 part per million. You take it away and you decrease atmospheric carbon dioxide by 1 part per million. You take away 50 gigatons and you decrease atmospheric carbon dioxide by 6.4 parts per million. Which means if we could start right now in 10 years, by 2030, we would have reached 350 parts per million, the safe levels of carbon dioxide. The argument for sequestering carbon is pretty clear, but how do we relate it to hunger? Carbon dioxide currently makes up 2/3 of all greenhouse gases that we emit. Greenhouse gases lead to climate change, increased atmospheric temperature, and thereby leads to floods, droughts, rains, extreme climate events. The top picture here is from this week from California, a fire tornado. Temperatures are predicted to rise, and many parts of the world will not be inhabitable anymore. The tropical belt will be hugely affected. This will lead to failed crops, lack of food, climate refugees, and climate wars in many parts of the world. All these factors and many more indirect factors are going to lead to more hunger. This is crucial for us to act on right now. However, this is what agriculture often looks like, a practice we're all too familiar with in some parts of the world, including India. The argument for stubble burning is that it's easy. It prepares the fields, gets rid of weeds, seeds, and pests. And yeah, it's easy. It hugely pollutes air, but it also reverses all the carbon sequestration that we've done. The moment you burn biomass, whether you're chopping a tree down for firewood or you're burning stubble, all the carbon dioxide that you've sequestered through agriculture goes right back into the atmosphere. Now you might think that this practice is done by less educated farmers who don't know better, and they don't know about soil life, and they don't know about these relationships that are so beneficial. So I'm going to engage you in a little example of innovation. This one comes from Norway. It's an award-winning innovation. Here it goes.
Did you know that the world population increase is estimated at 80 million people per year? Did you know that almost 1 billion people in the world are starving? We don't produce enough food for everybody. The world population needs more food. Because of this, the world would need to increase food production up to 60% to feed 9 billion people by the year 2050. The Western world demands ecologic food, which needs 60% more land per 1 kilo of food. This decreases food production, which is too small already. More and more pesticides are being prohibited, and weed and fungus are getting resistance toward more and more of the remaining ones. For more than 100 years, people have been steaming soil in order to kill it, yet no one has been able to do this in a sustainable way. Until now. Soil Steam International is using a patented technology that allows farmers to steam the soil down to 30 centimeters deep on free land. Yes, this means that they can kill nematodes, weeds, seeds, and fungus without using any chemicals. This technology gives the opportunity to grow vegetables, fruits, and berries with very low use of pesticides. By using soil steaming, the farmers can produce ecological vegetables, berries, and fruit in a more efficient and inexpensive way. When steaming the soil, we have learned that you can get up to a 40% larger harvest. We have also learned that many vegetables can be stored longer, and this might have an important impact on the food waste in the world. Trials done by Soil Steam International show that carrots can be stored up to 3 months longer, and this means that the world's waste of carrots can be decreased by more than 1 million tons per year. It's time to think fresh, healthy, and different. It's time to think green, sustainable agriculture. Soil Steam International is offering the world an opportunity to make more food, which is healthier and can be stored longer. It's time to act now.
So they talk about green sustainable agriculture, but everything they show in the video goes against everything organic farming teaches us. For me, this pitch leaves more questions than answers. For example, what does steaming soil do to the rate of land loss, the rate at which we currently lose land? Wouldn't that be accelerated? And shouldn't we be worried about using such technology? It claims to reduce weedicide and pesticide control, but without soil life, it will increase the use of fertilizers. It would increase the other harms that fertilizers do. And this is an award-winning innovation. Am I suggesting innovation doesn't have much use when it comes to food? No, I have another example for you. This one comes from the fisheries industry. And this is a beautiful example of how an idea, how an innovation can be developed.
1 in 5 fish that's caught is caught unintentionally, which means to say that it's not the fish that the fisherman targeted. New legislation says that fishermen can't throw this fish back anymore, they can't discard it. But due to a lack of technological solution, they still struggle to comply with the new regulations. I first heard about this problem when some Scottish fishermen were arrested in Norwegian waters, and as a student at the time thought it would be an interesting project to look at how a technical solution might be able to help address the issue. I spent the last 5 years working with engineers, scientists and fishermen to develop Pisces, a unit which fits to existing fishing gears and uses light to make fishing more selective.
Well, we know light has been used in fisheries in the likes of static gears and squid fisheries for many years, and fish can be both repulsed or attracted to light. So what we would like to do is try harness that type of behaviour of fish to actually improve the selectivity in gears.
Safety nets devices attach to fishermen's fishing nets and emit light. So a basic example of their usage is that one species of fish, say cod, like red light or mackerel like blue light, and the fisherman, depending on what he wants to catch and what he wants to repel out of the net, can program his fishing nets to emit a certain colour of light and catch the right fish.
We've done trials across Europe and will also be doing so in the US and in Southeast Asia. Our technology can reduce bycatch by up to 90%.
So we're asking you, the public, to help us in this project by pledging whatever you can really to help us get there. Because the oceans belong to all of us, now and in the future.
So I hope you see a difference between these two examples. Pisces was created for the user. It had a goal to help fishermen. They in fact have a subscription-based business model meant to help the people they claim to help. Now, with just these two innovations in mind, I hope you can see that not all innovations are created alike, kind of to say, not all that glitters is gold. Everything that's fancy, techy, and new isn't necessarily better, but we tend to judge it in a more fair way, in a more favorable way. We need to be more critical about how new innovation affects us. Some questions to ask is, where does the idea come from? Is it traditional knowledge? Has it been used before? Or is it new? And what can we learn from that? If it's used traditionally, what can we learn from that? If it's new, what does it compare to? What can we learn from that? The second point I want to make here is too often innovation and research is existing traditional knowledge from savage communities, typically indigenous communities and African communities, that are not respected and stolen of their knowledge, and it's then advertised as new Western knowledge. An example of this is insect as a source of food. Insects have been consumed across the world in many places. We just don't respect their traditional roots, and we've been promoting it as a new source of protein for the Western world. As an extension to the new Black Lives Matter movement, we need to be respectful about where knowledge comes from. In addition, businesses have hidden costs. When companies advertise a solution, they leave it for the consumer to figure out what the hidden costs are. And an example I like to give here is that no one's going to tell you that the cocoa beans for your chocolate drink were sourced from a farm that uses child labor. This is a real problem. Cocoa farms use children for work, and it's a source, it's a reason for increased child trafficking in many parts of Africa. If you don't know about a problem, you won't be in a position to really help it. So look for what the hidden costs behind anything are, where your food comes from, what are the bottlenecks in the supply chain. And lastly, we really need a change of mentality regarding concepts like growth. Growth and profits are too often criteria for innovation awards, as well as policies. When it comes to policies, and these are my closing notes in the talk, one example of policies are trade agreements that we see between many countries. There are bilateral and multilateral trade agreements. And NAFTA, TAFTA, CAFTA. The FTA in all these abbreviations stands for Free Trade Agreement. They're marketed as a means for increased economic growth, which in a way on paper you can claim that they are. But what they actually do is they create more competition with the global market. They take opportunities away from the local entrepreneur. They put money in the hands of large corporations and take away decent jobs. in return for poorer work conditions. This image, this graph, is taken from a documentary called The Economics of Happiness from 2011. It's just as relevant now as it was back then, and I recommend you to see it. The documentary talks about how GDP is a made-up metric that doesn't help happiness. An example they show to explain GDP is an oil spill or something disastrous. What an oil spill would do is that it would require money to be spent on cleanups. It would require money to be spent in hospitals because people will be falling sick. It requires money to be spent in many directions. And this is good for the GDP. On the other hand, there are projects such as community gardens, free food projects, material libraries that are good for the environment, that are good for people, that help connect neighbors together. But these projects hinder spending. They make people spend less. This is bad for GDP. So is GDP really a metric we want to go by? Are profits and the business model really something we want to judge innovations by? The last thing I want to show you is an example of something that I would call true progress, true innovation, because it meets what a society really needs. This example comes from Malaysia. I think it was started by a doctor who quit his job and started growing food so that he could provide healthy, safe, nutritious food to his family. The project took off.
Hello, welcome to our farm.
We named our farm Follow,
which stands for Feed Our Loved Ones.
That's our mission in a nutshell.
We're 6 family putting our heart and soul to grow organic vegetables for our family, friends, community, and the world.
But why an organic farm? Because over 99% of the vegetables grown in Malaysia use pesticides and chemical fertilizer. Just Google pesticides and read for yourselves. Pesticide exposure has been linked to all kinds of health problems, from skin disorders to cancer.
That's when we decided to start our own organic farm. Actually, we have 3, right here in JB.
Kompas, Kukop, and Banfu. Kompas is our original concept farm, Kukop is our big wellness farm, and Banfu is our compost and production farm.
We make our own compost because we believe we shouldn't waste anything. So we collect food scraps from restaurants and hotels. Then bring it here where the process begins. Come on, guys. Come on.
Compost is nature's fertilizer, power-packed with quality nutrients and tremendous microbes, so that our vegetables grow big and strong.
In fact, they grow so strong, they fight off pests themselves, and they don't need pesticides at all.
Our chief farmer is Shifu Alec. He's our mentor. He's one of the few farmers in Malaysia who insist on growing organic vegetables. Shifu plans what to grow based on the conditions of the soil and experiments with interesting vegetables not commonly seen in Malaysia. And we get the most diverse, nutritious vegetables possible. We want people to remember that our food comes from nature, not the supermarket. So we encourage our community to come back to nature weekly to pick up the most nutritious vegetables available and to bring their kids to play at the farm.
So this is us, Polo Farm. Make this your farm too.
That's the end of my notes. Every project you follow, every science piece you follow, I think in the end you learn life sustains life. Nature has the best ways to solve nature's problems, best solutions to nature's problems, and I think we should use it. I'd be happy to take any questions if there are any.
Thank you.